Welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 19 from the practice paper for the IGCSE 0580 Cambridge paper 2 non-calculator paper. And here we have a question all about functions. So we're given three functions: f of x equals 3x plus 2, g of x equals x squared plus 1, and h of x equals 4 to the power of x. So a function has an input, which takes the place of the x, and an output, which is the result of the operation that the function is represented by. So whatever you put in here is the input, and the output is what comes out of here. The input is called the domain, and the output is called the range. Some new notation that they have introduced into the syllabus, which I'm just mentioning now, although it's not mentioned in the question, just to get you ready for that type of question. So it says find h of 3, means find the output when you input, instead of x3, find the range when the domain is 3, when you just put 3 into this function. So h of 3 is basically wherever the x is in h, which is this function here, you replace the x with 3. So you find the function h first, which is this function here, okay, and then you replace the x with the number they tell you to input instead of it. So this is a function for this, and you simply replace the x with 3. So this is 4 to the power of 3, and we should know our cube numbers. This is 4 times 4 times 4, which is 64. 16 times 4, which is 64. The cube numbers, you should know them without, using a calculator. Obviously, we can't use a calculator here. So, the square numbers are 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, 9 squared, 10 squared. And the cube numbers are 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125. Right? The rest of them, you don't really need to memorize them so much, although if you did, it would probably be better for you. Okay? But at least these you should know by sight. These cube numbers, you should be able to recognize them by sight. If you're asked to find what 5 cubed is, 3 cubed, 2 cubed, 4 cubed, you should be able to say it straight away. Okay, so it's important for you to have an idea of what those numbers are in your mind, so that you can get to the answer very quickly in these non-calculator papers. So then it says find f of g of 1. Okay, so basically what's happening here is the 1 is the input of the function g. And then the output of g1 becomes the input of f. So you're kind of going backwards. So there's two ways of doing this. One of them, we can find what the function g1 is first. So we go to the function g, and we put 1 instead of the x. So you have 1 squared plus 1, which is going to give you 2. So we know that g of 1 is equal to 2. And then the second thing we do is we take g of 1 and put it into f. So we're taking f and we're putting inside it g of 1. So we're going to basically put 2 instead of the x inside function g. So the input of, it's basically saying that the input of the function f has to now become g1. So you find what g1 is, which is 2, and you put that inside function f. That gives you f2. So now we go to function f, which is this one here. Replace the x with 2. So 3 times 2 plus 2, that's going to give you 6 plus 2, which is going to give you 8. Okay, that's one way of doing it. There's also an alternative method which you could use, okay, although I prefer using this method. And you could, if you want to, find the function f of g of x first. You could find what is this function first, and then you can put the 1 inside the composite function. So you can say, okay, let's find what f of g of x is. Basically, what it means is put function g of x into function f. So put x squared plus 2, x squared plus 1, replace this into function f. So instead of the x in function f, f of x is 3x plus 2. If I have x squared plus 1, I'm going to replace the x with x squared plus 1. So 3 times x, so 3 times x squared plus 1. So this took the place of the x, and then plus 2. That gives you 3x squared plus 3 plus 2, which is 3x squared plus 5. So now that's f of g of x. So f of g of 1 would be 3 times 1 squared plus 5, which is 3 plus 5, which is 8. Same answer. I prefer this method. This is a bit too long. Unless they already told us to find f of g of x. In the previous question, this is much quicker. You just put g1 in here. You can even do it in your head very easily. Put g1 in here, it's going to become 2. Put 2 in here, it's going to be 3 times 2. 6 plus 2, 8. You get the answer straight away, but you should show your steps. So there's the answer for 19 part B. Now we're going to go to 19 part C. Okay, now I have just copied the functions so I don't have to keep going up and down on the page. So I've copied the functions here so we can see what they are when I'm doing this. So now it says find g of f of x, which is the opposite of what we just did. Okay, they want us to find g of f of x in the form ax squared plus bx plus c. So they want us to now find g of f of x. I've kind of done something similar in the previous question, this other method I showed you, but this is like the other way around. So this time you've got to put inside the function g, the function f. So it won't be the same thing. So it's kind of good that I showed you that so you can see that. So I've got to put inside function g, f of x. So this has to go inside this function. So instead of x squared, I'm going to put, so basically if I write it like this is g of 3x plus 2. I've got to replace the x in this function with 3x plus 2. So it's going to be 3x plus 2 squared. And then I'm going to have a plus 1 at the end. So x squared plus 1 becomes 3x plus 2 squared plus 1. And I want to have it in this form. So I've got to simplify this. I've got to expand the brackets. Now, expanding the square brackets is something important for us to know how to do quickly. So when you have a square bracket, a bracket that's squared, it's easy to do using the pattern. The pattern is where you square the first term. So you get 9x squared. Okay, and then you don't forget the middle term. A lot of people, they say 9x squared plus 4, and that's a very common mistake. No, you have to multiply these together and double the answer. That gives you 6x doubled, that's plus 12x. You multiply them together and you double the answer. And then you have your plus 4, and then you have your plus 1 at the end. You end up with 9x squared plus 12x plus 5. Remember, 3x plus 2 squared means 3x plus 2 times 3x plus 2. It doesn't mean just square everything in here. And if you expand this a long way, you have 9x squared plus 6x plus another 6x. It'll always be this times this and that times this will give us the same value. That's why we multiply them together and double it. That's like the pattern. And then 2 times 2 is 4. So don't forget the middle term. Very common mistake to forget the middle term. Then it says find x when f of x is equal to g7. So f of x is 3x plus 2. We want to find what x is when this is equal to g7. So I've got to take g7. G7 is when you replace the x squared with the x with 7. Okay, g7 is going to be equal to 7 squared plus 1. This is going to be 50. So when 3x plus 2 is equal to 50. 49 plus 1, which is 50. So 3x is equal to 50 minus 2. 50 minus 2, which is 48. So 3x is equal to 48. 3x is equal to 48. So x is equal to 48 over 3. Okay, so x is equal to 48 over 3. So 3 goes into 4 one time, remainder 1. 3 goes into 18 6 times. Okay, so if you're not sure about this, of course, no calculator, you can just do this. Short division, 3 to 4 goes 1, remainder 1. 3 to 18 goes 6. There is no remainder, so that's 16 exactly. So x equals 16, and there's the answer to part C. Okay, so we've got here a question about substitution, composite functions, another type of composite function where you have in terms of algebra, and then you have this function equation. Now part E. Find inverse f of 1. So now we've got to find the inverse function. This means find the inverse function f. That's what that means. Okay, so we've got to find the inverse. To find the inverse of a function, you basically, what you're actually doing is you are switching around the x and the y in the equation. You're making the domain the range and the range the domain. X and y swap over. Okay, so what we do first, I take the function f of x as it is. And this is how I like to do it. People might do it in different ways. Then I call the f of x y. So I have y equals 3x plus 2. Okay, and then at this stage, I switch. I like to do this at this stage. A lot of people, they don't do this until the end. I like to do this at this stage, then you don't forget to do it at the end. So I like to switch the X and the Y. So switch X and Y. It's just basically, when I say switch X and Y, it just simply, wherever you see Y, you call it X. Wherever you see X, you call it Y. And then we make Y the subject. When we made Y the subject, we will end up with the inverse. So you're doing X minus 2 equals 3Y. Subtract 2 from both sides and divide up both sides by 3. So you end up here with X minus 2 over 3 equals Y. So this now is your inverse function, X minus 2 over 3. Now, if you forget, or if you're used to switching at the end, many students make the mistake of, they'll have here Y minus 2 over 3 equals X, and then you're supposed to switch. But because they're kind of like finished here almost, so a lot of students forget to change it, and they put Y minus 2 over 3, and that will lose a mark. Right? So that's why I like to switch at the beginning, this stage here, so you can't forget at the end. That's the reason I do that. Okay, so this is the algebraic way. This is the way that you should really answer your question, such a type of question. Okay, but I want to show you how it works in terms of flowcharts. This is a nice way of understanding functions. But I wouldn't use a flowchart in the exam. All right, for a simple one like this, maybe it's okay. But just for you to understand what's happening when we do inverse functions. So first of all, we think about the function f of x. So basically, you're taking your input, which is x. Okay, and with that input, you are doing an operation. And the operation first, when you got 3x plus 2, is you're multiplying it by 3. That's the first thing. That's the first operation that has to take place. When you put function here, this is your operation. You must first multiply it by 3. And that will give you your 3x. Okay, so you're starting off with x, multiplying by 3, that gives you 3x. And then we're adding 2 to it, which gives us our function, final version of it, which is 3x plus 2. So whatever you put in place of x, the same operation will take place and you get the correct output. Now for the inverse function, we're going to start from here. The inverse function is where you start from the end. So this is going to be my x. I'm going to go in this direction and I'm going to do the opposite operations. So the opposite operations in the opposite order. So I'll start with this. Instead of plus 2, what's the opposite or the inverse of plus, of adding? Subtracting. This will give me x minus 2. Okay, and then I've got to do the opposite of multiplying, which is dividing. So I'm going to end up with x minus 2 over 3. And this is my inverse function. Okay, so that's how you find the inverse. You do the opposite things in the opposite order. You start from the end, you end up with the inverse function. And you'll notice what the inverse function does. It basically takes a value and it undoes the operation of that value. So for example, if I put instead of x, for example, the number 10, you multiply by 3, you get 30. You add 2, you get 32. So now let's start here with 32. You subtract 2, you get 30. You divide by 3, you get 10. So it basically undoes, the inverse function undoes what the original function does or did. Okay, so it undoes the operations of the original function and it takes you back to something. It'll take an input back to what it originally was. Okay, before you put it in the original function. Okay, so that's the inverse function. All of this you don't really need to worry about too much. It's just a little illustration to you of how you can use flowcharts and what an inverse function actually does. It's just a bit extra there for your information. Right now, for part F, it says here, find g of x over f of x plus x. So let me just get rid of this, put it up there. And we need these, so let me bring these down here. Okay, so is that the last part of the question, F? Yes, okay. So it says here, find g of x over f of x plus x. Okay. Give your answer as a single fraction in its terms of x in its simplest form. So g of x, which is x squared plus 1, over f of x, which is 3x plus 2, plus x. So we got to rewrite this as one single fraction. Okay, so it's the same when we're dealing with algebraic fractions and general fractions with normal numbers, exactly the same thing. Okay, so for example, if I had a half plus for example, 4. I wanted to add them together. Like, what you need to do is make the denominators the same. Okay. So, I mean, we know this is going to be 4.5, but we can't write that for here. So basically you make the denominators the same. So this is like 4 over 1. So we can say this is like x over 1. Okay. And then I have to think of how to make this denominator the same as this. I multiply by 2. So I multiply the numerator by 2. And here we got to think of making the denominators the same. So I need to make this into 3x plus 2. So I multiply the numerator also by 3x plus 2. And then now I can combine them into one fraction. Now I can say this is like 1/2 plus 8 over 2. So I can say 8 plus 1 is 9 over 2. I can add them together. I can write them as one fraction. So the same thing I can do with this now. Once I have them as the same denominator, I can write that single denominator 3x plus 2. And then this will become x squared plus 1 plus x times 3x plus 2. Now what it looks like has happened, okay, is that I've multiplied 1 by this, I multiply 3x plus 2 by that, and then multiply these two together. That's another way you can think about doing it. So you have a over b plus c over d. It looks like what you're doing is you're multiplying these two together, you're multiplying those two together, and the sign comes here, then you multiply these two together. And it's basically the same as making this as BD, making this also as BD, make them the same denominator. That has to be multiplied by D, so it becomes AD. That has to be multiplied by B, so that becomes BC. So you end up with AD plus BC all over BD. Okay, so there's two different kind of ways of thinking how to do it, but they're both basically essentially the same thing. They both are basically making the denominator the same, just like we do with normal fractions. So now we have to simplify. So it's giving your answer as a single fraction in terms of x in its simplest form. So we combine them in now as one fraction. We have to now simplify. So to simplify, I've got to expand this bracket. So this is x squared plus 1, and that's going to be 3x times x, which is 3x squared, and x times 2, which is 2x. And that's all over 3x plus 2. And now I can combine the like terms. I've got 4x squared plus 2x plus 1 all over 3x plus 2. No need for a bracket around this because it's not multiplying anything. And there we have our answer. Now, is this in its simplest form? You should check. I mean, it looks like it's going to be, because if it cancels out, it wouldn't be a fraction. But you should always try and see, can you factorize this numerator? Okay, can you factorize it? I don't think we can factorize it. Okay, there's no way it can be factorized, I don't think. 2 numbers multiplied to give you 4 and add to give you 2, no. So you can't factorize it, so therefore this is the simplest form of this answer. 4x squared plus 2x plus 1 all over 3x plus 2. If it's possible to factorize it and you get a common factor that cancels out with the denominator, then you could simplify it further. In this case, no. And the question does state very clearly it's going to be a fraction in the end. So this won't really cancel out anyway. All right, but it's always good to make a check in case it can simplify further. And there we have the answer to this question. Oops, what did I do? Okay, and that's the answer to question part F. Now we're going to go to part G of this question. Okay, let's bring this down here. Oops, what am I doing? This should be up here. Okay, so now the last part of this question says find x when h inverse x equals 2. Right, so now we're dealing with the function h, which is this exponential equation or exponential function. How do we deal with this kind of question? A lot of people get confused by this. Why? Because a lot of people say, okay, let's find the inverse of h. So this is the thought process that a lot of students go through. We need to find the inverse of function h. Let's find it. Okay, can't be such a difficult thing. The h of x equals 4 to the power of x. They'll say y equals 4 to the power of x. Switch the x and the y. X equals 4 to the power of y. I need to make y the subject. Oh, how do I do that? I don't know how to do that. We don't know how to do that in IG Maths because you've got to use what are called logarithms. Right? There's no point in going through the whole topic of logarithms just to do something which you'll end up seeing is really simple. Right? So we can't go down this road of finding the inverse of function h. Okay, because we don't have the maths skills in IGCSE maths in order to do that. Right? So we've got to think in other ways of doing that. Now, one of the things that we should understand with inverse functions is, as I mentioned before, an inverse function and the original function, they cancel each other out. And basically, what I've shown you here is an illustration of that. That if you apply the inverse function to the original function, you end up with what you started with. So if you do the composite function of the inverse function with the original, or the other way around, you'll see that basically they cancel each other out. Okay, so if you do this or this, if you put the original function inside the inverse, or the inverse inside the original, if you find the composite, they basically cancel each other out, leaving you with whatever's inside the bracket. Okay, so if I put, for example, inside here, okay, the inverse function, you'd end up with just x. Okay, so if I put 3x plus 2 in here, okay, sorry, x minus 2 in here, over 3. If I put x minus 2 over 3 in here, you multiply by 3, you get x minus 2. You add 2, you'll get x. And if I put inside the inverse function the original function, so if I put 3x plus 2 in here, I'll first of all take away 2, I'll get 3x. And then I'll divide by 3, I'll get just x. So putting the original function, the inverse function in here, or the inverse function here, they cancel out. So when you find the, if you find the composite of the original function with the inverse, they cancel out. Okay, and vice versa. So we can use that principle here in this question. If I want to find the inverse of h of x equals 2, and I want to find what x is, what I can do is I can take the original h of the inverse function. Okay, I can find the composite of these two. And if I take the h of x of this side, okay, if I apply the function h to this side, I must do the same to the other side. Just like when I add something to both sides of the function of an equation, or I subtract the same thing from both sides of the equation, I multiply both sides of the equation by a certain number. If I take the function h of this side, I must do the same to the other side. Now these cancel each other out, leaving you with x. So x is equal to h2, and that's something we can find, because h2 is basically putting 2 instead of the x. That's going to be 4 squared, which is going to give you 16. Simple as that. That's one way of thinking about it, which is probably the easiest way. There's also another way of thinking about it, which I've explained maybe in some of my earlier videos on this topic. Okay, and that is basically, you can think about it like this. You want to find the inverse hx equals 2. So first of all, you think, where did you put, what do you do when you solve this? If it just said h of x equals 2, what would you do? What would you do if it was h of x equals 2? Well, we would replace, the h of x with 2. We would say, okay, 2 equals 4 to the power of x. So what we do is, if it's the inverse, we do the opposite. We don't put the 2 doesn't go here. No, the 2 goes here instead. You put it in the other place. So if it was hx equals 2, we would have said 4 to the power of x equals 2. Okay? But the question is not that. It's the inverse h of x equals 2. So you just put 4 to the power of 2. You put the x in the other place that you normally would do it. Now, this is an important concept for when we do graphs of functions and dealing with inverse functions. It's especially when you don't know what the function is, it's important for us to understand what I just said for those topics. So it's not something that you could ignore because we have this. It's something that's important for us to understand. Basically, your x becomes your y and your y becomes the x with the inverse. So if it was this, the x takes the place of the y, right? So the, hx equals 2, basically the number here, the 2 takes the place of the y. But because it's the inverse, this takes the place of the x instead. Because it's like you've swapped them around. So this was the y, so it takes the place of the, y normally, but now it's going to take the place of the x. Okay, so you can think of it in that way. Okay, as I said, this is probably the easier way of dealing with it, but we should understand this concept. So if you ever had to do, if you ever had to do something like this, you say to yourself, okay, if it was a straight line graph, if it was a graph question and you wanted to find, the value of this and you didn't know what the function was or anything, you would say, okay, I would normally put the x, okay, I would normally draw the line x equals, or in this, I'd normally draw the line y equals 2 and see where it hits the function h. Because this is the inverse, I have to draw the line x equals 2 instead and see where it hits the function h. So same kind of thinking, I would normally put the 2 in place of the h of x, but now I've got to put the 2 in place of the x instead. Okay, so that's a couple of different ways. This is probably the easiest way to think of it, but this way that I'm mentioning here will come in useful, especially when you're doing graph questions and functions. So there's the answer to question part G, and that completes the question, which was question number what? Question number 19 from this paper, the practice paper from 2025 for the Cambridge Paper 2 Extended. Other questions from this paper you'll find in the playlist that will appear in the top right of the screen at the end of this video. Other questions from the topic of functions you'll find in this playlist over here. So questions from the topic of functions and input in inverse and composite functions and so on can be found in the playlist that will appear in the bottom right of the screen at the end of this video. Questions from the topic of functions in general you can find in the playlist here, and the old function questions from the previous paper or previous syllabus, which would be very much relevant to now, you'll find in the playlist over here. Thank you for watching and see you soon.